G'day. Albedo is a scientific measure of a surface or a body's reflectivity. It's the ratio of reflected energy over incident energy between 250 and 2500 nanometers. The Earth's albedo is approximately 0.35, meaning that we reflect 35% of the Sun's energy. The rest is turned into biomass and heat. It is this heat that keeps the Earth's lower atmosphere at around 288 degrees above absolute zero. If the amount of energy being reflected were to be increased, then there would be a corresponding drop in temperature. A 1% increase in albedo, or solar reflectivity, would be expected to result in a 1% drop in global temperature. That is a 2.88 degrees centigrade decrease. More than enough to offset current global warming. This rather complex diagram shows how the Sun's energy interacts with the Earth. The area of concern is the trapping of heat in the lower atmosphere by greenhouse gases, which is what is causing global warming and climate change. If the amount of energy converted into heat on the planet's surface can be reduced, then the effect of global warming from our greenhouse gases can be offset. This image shows the varying temperatures of roofs in Atlanta. These individual hotspots accumulate to form hot cities, urban heat islands, where local temperatures are several degrees hotter than the surrounding countryside. These are plots of Melbourne's urban heat island, and as you can see, it's quite pronounced. Increasing the albedo of our roads, roofs and footpaths, as well as the strategic planting of trees to shade buildings, could eliminate our urban heat islands, as well as save around 60% on electricity use for air conditioning, along with electricity generation's associated CO2 emissions. Such a citywide decrease in temperature would reduce the number of days of and the amount of photochemical smog, which would result in reduced health costs and longer lives for those who live there. It is estimated that such measures could save Los Angeles $500 million a year when health cost savings are included. This is a graph showing the relative albedo of various roof coatings and their surface temperature differences. Titanium dioxide white is the best. Even with tint, these paints still reflect in the infrared. The best rule of thumb to test a material is to put your thumb or hand on it after it has been in the sun for a while. This graph is from the Stern Review, showing the business as usual growth of emissions and the required 30 gigaton reduction to keep CO2 levels under 450 parts per million, and hopefully keep global warming under 2 degrees centigrade. Increasing our collective albedo could help with this. If all urban areas were to increase their albedo by 7.5% as in the Los Angeles modelling, or more, then it would not only reduce electricity use and its associated CO2 emissions, but it would also provide an offset to global warming. The Albedo Offset Calculators program was written to demonstrate the offsets to global warming that increases to urban albedo could provide, and also, more accurately, for local surfaces in square meters such as a road, roof, footpath or a city. The global albedo offset calculator shows that for a 0.1 or 10% increase to the albedo of our urban areas, I selected 1% of this image's area by the brightness of the city lights, would offset 40 gigatons of CO2e. This would offset about 5% of current global warming, or it would when I originally wrote the Albedo Calculators program. Global warming has increased quite a lot since 2008, but the program allows one to set current global warming as well as a price for CO2. A 5% offset to global warming may not sound like a lot, but it is the amount that we hope to reduce our actual CO2 emissions by 2020. This image shows some typical urban albedo values. Once one becomes aware of the effect that low albedo surfaces have upon local and global temperatures, it becomes apparent that large increases to urban albedo are possible simply through our choices of materials for roads, roofs and footpaths, as well as for the walls of buildings exposed to the sun. By the way, the word albedo comes from the ancient Greeks' white shield, their alb. I suppose that the strategy would have been to meet enemies from the east in the morning and enemies from the west in the afternoon, in order to dazzle one's opponents to best effect. Thank you for taking the time to view this video. Best hopes and wishes for us all.